Hey kids, we're going to try to go through this pretty quickly today. I'm going to take D1, D2, D3, D4, and D5 work, okay, homework or quizzes, and I'm going to do the solutions for you. Now, we did 1, 2, and 3 together in class way back when we did this, okay? It was a Friday like a week ago or 2 weeks ago, all right? Density equals mass divided by volume. I'm trying to find the density, so I use that formula right there, D equals M over V. Plug in my mass, plug in my volume, do the division. You'll notice none of the units cancel out. Our answer is 12 divided by 0.33 or 36.4 kilograms per cubic meter. All right, the second problem, I'm asking for mass of a 12-liter object, that's volume, with the density of this. All right, well, mass is going to be density times volume. Mass equals 3.5 kilograms per liter times 12 liters equals 42 kilograms. Okay, my liters, which are on the bottom of the density, cancel with the liter here from the volume, and I get mass. All right. You'll notice this looks a lot like a one-step conversion. This is what we call dimensional analysis. We did it way back when. It really helps if you've learned how to do it. You can solve all of these problems using dimensional analysis and never even worry about these formulas, okay? But in order to do that, you have to know what kind of units are you going to expect for density, what kind of units do you have for volume, and what kind of units do you have for mass, okay? And then you're just making sure that your units cancel out and you get the units you desire in the answer. All right, I did this for two reasons. One, I wanted to check out and see if the pencil would show up well in the video, and it does. All right, I'm going to move the camera, and we're going to do 4, 5, and 6. Before I do that, though, I'm going to show you this sheet right here is in your notes. You can access it. We went over this together in class, okay? Remember, this means units of, all right? And density is defined as mass per unit volume, okay? It's in your notes. All right. Here we go, 4, 5, and 6. Okay, what is the start here. What is the density of a solid with a volume of 6 cubic centimeters and a mass of 8 grams? Okay, density equals mass divided by volume. So we're going to take our mass of 18 grams and divide that by 6 cubic centimeters, and that looks easy, right? 3 grams per cubic centimeter. Okay, all right. Number 5, what is the mass of an object with a density of 62.4 pounds per cubic foot and a volume of 2 cubic feet? Okay, well, mass, let's just say mass has units of pounds in this case, right? I'm going to start with pounds on top, 62.4 pounds per cubic foot. All right, that's my density. I'm going to multiply that by my volume, which is 2 cubic feet. Okay, those units cancel out. Notice you do not cube the unit, right? That is already a volume. Okay, don't cube the unit. If the 3 is on the outside, we would have to cube the number also. Okay, so you're just doing 62.4 times 2, 124.8 pounds. All right, great. Number 6, what is the volume of an object with a density of 13.1 grams per cubic centimeter and a mass of 73 grams? Okay, we want volume. Let's do this. 13.1 grams. I need cubic centimeters on top because I'm looking for a volume, right? I'm using dimensional analysis this time. 73 grams. Okay, my grams cancel out, and my units left over with are cubic centimeters. Any number on top is multiplication, any number on the bottom is division. So I do 73 divided by 13.1, and I get 5.57 cubic centimeters. Okay, there you go. That's 4, 5, and 6. Let's go to the next page. This is the next page. We're still on day 1. And these are 2 problems that I took from your EOC and I modified them. How did I modify them? I crossed out this and wrote 40. I crossed out those and wrote numbers down. I crossed out that and said find the lowest density. Okay, and we've got rocks and cylinders. Now it might be a little tricky to see the water levels. So we talked about this in class. But we're starting at 40 on all of these, which is right here. Okay, 40, 40, 40, and 40. Okay, and our volumes are measured in milliliters. You can kind of see it on there. This one is at 60. This one is at 100. This one is at 85. And this one is at 75. Okay, so if I want to know my volume, I take the volume before the rock was added, right? And I subtract that from the volume after the rock was thrown in. Okay, so 60 minus 40 can be 20. 100 minus 40 is 60. 85 minus 40 is 45. And the last one is 35. Okay, those are all milliliters. What I'm going to do here is I'm going to put down volume in milliliters. Okay? 20, 60, 45, and 35. All right, now my density, we said, is equal to mass. Sorry, you almost can't see that. Density equals mass divided by volume. So all I got to do is take these numbers and divide by those numbers. Right? In each case, I take 50 divided by 20. That looks like 2.5. All right, 175 divided by 60. That's calculator time. Okay, 2.92. 200 divided by 45 is 4.4. That's pretty high. And 130 divided by 35 is 3.7. All right, 3.71. Okay, which one had the lowest density? Well, that would be rock and cylinder 1. Okay, 2.5 is a lot lower than the other options. Okay, awesome. So I just circled rock and cylinder 1. All right, that's how you'll do these. You'll probably have one like that on your final. It's a lovely question. All right, this one's simpler, but it's much the same, right? We're given mass and volume for all these samples, and we're told to find which one has the highest density. Okay, again, I just take stuff in column 1, divide by the stuff in column 2, right? Because density equals mass over volume. All right, my units then will be grams per milliliter, just like up here, there were grams per milliliter on the previous problem, okay? All right, so 8 divided by 5 is 1.6. Okay, 7 divided by 4 is 1.75. 6 divided by 3 is 2. And 9 divided by 6 would be 1.5. Okay, which one has the highest density? Well, that would be the raw sample 3. Okay. All right, there it is. Okay, 2 is higher than the others. All right, that's the end of day 1. Let's move on to day 2. Okay, day 2. Switching gears here. Now we're looking at atomic number, isotopes, and atomic structure questions. All right. The atomic number of sulfur is 16. What does that tell me? That tells me that this thing has 16 protons. All right, so I wrote a 16p for protons. Consider an isotope of sulfur whose mass is 32. All right, if that isotope has 32 mass and 16 protons, 32 minus 16 means there are 16 neutrons. So I'm going to write that up here also. All right, that's an N, believe it or not. The total charge carried by the nucleus of a neutral atom of this isotope is, and these are my choices. All right, it's got 16 protons. Each proton has a +1 charge. So my charge is plus 16. Neutrons have no charge, so they do not affect the charge. We're only looking at the nucleus of the neutral atom. Okay, if we were looking at the entire neutral atom, it would be 0, right? Because it also has electrons, especially if it's neutral. So it's plus 16. All right. Next problem. This one's kind of wordy. According to the table above, how do the two isotopes of chlorine compare in terms of the numbers of neutrons, electrons, and protons per neutral atom? Isotope number 1 contains. All right, so we're looking at chlorine. So I saw people do this, and I think it's brilliant. Cross out the potassium row, cross out the fluorine row, cross out the carbon row. Okay, ignore those. They have nothing to do with this problem. Okay, we're only looking at the isotopes of chlorine. Isotope 1 contains, and then we have neutrons, electrons, protons. All right, let's look at isotope 1. It does say they're neutral. That's important. Atomic number 17. Okay, if it has 17 protons, it is always chlorine. So we know that isotope 1 has 17 protons, and isotope 2 has 17 protons. Otherwise, it's not chlorine. Isotopes are only different by the number of neutrons. 35 minus 17 will give me 18 neutrons, right? Take the mass number minus the atomic number. Over here, 40 minus 17 will be 23 neutrons. And because they're neutral, they have to have the same number of electrons as protons, so they both have 17 electrons. And for that, I write an E17, E minus. Okay, that's pretty small. 17p, 18n, 17e minus, 17p, 23n, 17e minus. Okay, the only thing different about isotopes is the number of neutrons in the nucleus. All right, so now we're going to go down here and find that. Let's start 17 protons. That's wrong. 18 protons, that's not right. 17 protons, 17 electrons, 35 neutrons, that's not right. It's got to be D. 17, 17, and 18, true. 17, 17, 23, true. Okay, so the answer is D. All right. All you got to do is figure out what it contains, find it in the answer. All right, circle it. Okay, number 3. We've got strontium-88 and strontium-90. Let me move the camera if I can. Represent strontium isotopes with mass numbers 88 and 90 respectively. Which of the following features is different for a neutral strontium-88 atom and a neutral strontium-90 atom? The only thing different, okay, both atoms are neutral, is the number of neutrons. So it's C. All right. Okay, number 4. Which of the following statements best describes the electron cloud of a neutral atom in terms of its density and charge? All right. Well, electron clouds are not very dense and they are negatively charged. So that would be C. Not very dense, negatively charged. All right. Number 5. Atomic number of oxygen is 8. What does that mean? That means it has 8 protons. O, 17, right? Oxygen 17 represents an isotope of oxygen with a mass number of 17. What does that mean? Well, 17 minus 8 would give me 9 neutrons, okay? In a neutral atom of this, the number of electrons is equal to, well, if the charge is 0, right, then that means that my protons are equal to the number of, not neutrons, electrons. That's why I do this in pencil. All right, protons are equal to electrons. 8 protons, I got 8 electrons. B is my answer. Hurrah! Let's move on. Next page. Okay. Now these problems are pretty much exactly the same, almost. Only I changed them up some on you. Atomic number of strontium is 38. Atomic number tells me protons, so I got 38 protons. Consider an isotope of strontium whose mass number is 88. Okay, 88 minus 38 means 50 neutrons. The total number of neutrons in the nucleus of a neutral atom of this isotope is 50. Hey, that's not so hard. All right. Wonder how I got that? 88 mass number minus 38 atomic number gives you 50 neutrons. All right, according to the table below, 2 isotopes of fluorine. Once again, let's pull out our red pen and we'll cross out everything except for the row that contains fluorine. So we'll cross out chlorine because it doesn't apply, cross out potassium, it doesn't apply, cross out the carbon because it doesn't apply. All right, we got 9 protons. 19 minus 9 is 10 neutrons, so 9p, 10n. And over here we've got 9p, and 25 minus 9 is 16 neutrons. That's a lot. Okay? Alrighty. According to the table above, blah, 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 there are neutral atoms, so this has 9 electrons, this guy has 9 electrons. All right, protons and electrons are the same if it's neutral. Otherwise, it would have a charge. So let's just find 9 protons, 10 electrons, not true. 10 protons, not true. 9 protons, 9 electrons, 10 neutrons. Hey, that's true. 9, 9, and 16, that's also true. The answer is C. Okay? Awesome. Alrighty. Let's roll on down to number 8. Okay, 7 was C, 8. Here we go. Which of the following is true for neutral atoms of these isotopes? Okay, oxygen 17 and oxygen 20 represent blah, blah, blah. Okay, this guy has 3 more neutrons than that guy. O20 has 3 more electrons? Not true. They both have the same number of electrons if they're neutral atoms. 3 more neutrons? Yes, that's true. So B is true. 3 more protons? Not true. Same number of protons as that. That is true. So both B and D are true in this case. I threw that one in there as a little extra something for you guys. Make sure you read all the answer choices, just in case there's, a better one. Pick the best answer. All right. Number 9. Which of the following statements best describes the nucleus of a neutral atom in terms of its density and charge? A nucleus is highly dense and positively charged. That's A. Okay. And last but not least, number 10. The atomic number of oxygen is 8. O17, or oxygen 17, represents an isotope of oxygen with a mass number 17. In an atom of oxygen 17 with a 2 minus charge, the number of electrons is equal to. Atomic number is 8. That means I got 8 protons. Okay? I'm looking at a 2 negative charge. Right? If my charge is equal to 2 minus, I have to have more electrons or more protons? I have to have more electrons, right? Electrons are negative, protons are positive. So I've got 8 positives and 10 negatives, right? So I have 10 electrons. So the number of electrons is equal to 10. All right, there you go. Okay, that's 14 minutes. We're going to stop and pick up with another video.